My name is Perry Kelly and I'm the CEO of Mulpin Research Laboratories. I would like to introduce Rodney Green, who is our lead inventor with over 40 years of experience within the industry. Rodney will be conducting the demonstration today on Mulpin technology. I'm sure you'll be impressed with what you're about to see, but first, let's hear a little bit about Mulpin.
Rodney has written many internationally published articles on leading radio electronics, including his famous Dioradyne radio technology. Mulpin Research Laboratories have developed a new Gen 1 printed circuit board and component technology which will change the PCB industry as we know it. What you're about to see is a proof of concept prototype. The main benefits of Mulpin are reduced circuit board size at least 50% or better, dramatic increase in heat dissipation, increased board life due to less heat buildup, self-screening from electromagnetic radiation, electromagnetic interference, and electromagnetic pulse. Mulpin components automatically harden the PCB, giving protection from any unwanted elements. Mulpin is vibration-proof, dust-proof, and waterproof, therefore can be used in any environment. Space, desert, ocean. There is no industry that Mulpin will not touch. Aerospace, aviation, automotive, military, communications, shipping, and domestic markets, to name a few. The aim of these tests is to demonstrate that the new Mulpin printed circuit board will perform after being subjected to a large amount of electromagnetic radiation. The Tesla coil produces around 1 million volts of high-frequency energy in the form of what can be called man-made lightning. Rodney Green will be the person conducting these tests at the SciTech premises in Perth, Western Australia. He'll be testing both the Mulpin PCB and a conventional PCB from a leading brand, off-the-shelf portable radio. In addition to the Tesla coil test, he'll be exposing both the Mulpin and the conventional PCB to 800 watts of microwave radiation. This is a particularly brutal test, designed to emulate as closely as possible the effect of the radiation from a nuclear bomb, designed to wipe out the power grid and all electronic equipment, for example, within a city. Rodney will start by demonstrating the conventional circuit board against the Tesla coil. He will switch on the radio to show that the circuit board is working. He will now unplug the circuit board from the radio. The conventional PCB is now being placed in position for the Tesla coil test. The PCB will be zapped twice. Rodney will now remove the PCB and plug it back into the conventional radio. He is now turning it on. There is no sound. The conventional board has been destroyed by the Tesla coil's 1 million volts, and the radio is not working. Rodney will now test a conventional PCB in an 800-watt microwave oven. Both the Mulpin and the conventional PCBs will be placed in the microwave, one at a time, in the presence of a half a cup of water. The water is present to ensure that reflected microwave energy will not return to and damage the microwave generating magnetron. Because the first conventional PCB was destroyed by the Tesla coil, Rodney will be using a new conventional PCB. He's now demonstrating that the off-the-shelf radio is working. He is now removing the conventional PCB from the radio. Rodney now places the conventional PCB into the 800-watt microwave and is setting the timer. As you can see, the PCB has now been fried within 5 seconds. He is now placing the conventional PCB back into the radio and is now turning it on. There is no sound. The conventional board has been destroyed by the microwave, and the radio is not working. Rodney will now do the same Tesla coil test using the Mulpin circuit board. Note that the Mulpin PCB is numbered, and the same board will be used in the Tesla coil and the microwave. He will demonstrate that the Mulpin circuit board is working by plugging the Mulpin PCB into the test radio receiver and turn it on. Rodney will now place the Mulpin circuit board in position for the Tesla coil test. Again, we will zap the Mulpin PCB twice with the Tesla coil. Now that the Tesla coil has done its best to damage the Mulpin circuit board, Rodney will now place the same board that was just exposed to the Tesla coil into the microwave. In goes the Mulpin PCB, and he set the timer. The microwave has been stopped at 12 seconds. No visual damage is apparent. Rodney is now reconnecting the Mulpin PCB into the radio. And is turning it on. And it's functioning perfectly. The experiment is now complete. And the Mulpin PCB has successfully demonstrated the indestructibility of Mulpin technology. This truly is a breakthrough for the PCB industry and Mulpin internationally. This concludes the Mulpin test.